10 degrees. Then we have a vector here. This is, let's call this 5 Newton. Let's call this one 10 Newton. So how do you resolve these components? Now, for every component of this, for every one of these vectors, they are in the x and the y components. There's an x component, there's a y component. For this 5 Newton, for instance, it is acting in the y-axis and in the x-axis as well. So we'll look for the y component. How much of this 5 Newton is working in the y-axis and how much of this is working in the x-axis? So we'll now have, let's start from this 20 at the top. For y components, we'll now look at the positive y and the negative y. So the positive y, we have 20 Newton sine 90 plus 5 Newton sine 20 plus 10 sine 0 plus, there's this 10 here. Then we have this other 10. That would be minus 10 sine 10. That's for the y component. And for the x component, we'll have the same values again, but now consider positive x and negative x. Meaning we now have 10. Okay, let's start from 20 again. 20 cos 90, okay, plus 5 cos 20 plus, okay, no, that's for, okay, plus 10 cos 0 minus 10 cos 10. That's for this 10 that is here. Now, if we resolve this, say we resolve 20 sine 90 plus 5 sine 20 plus 10 sine 0 plus, okay, sorry, minus 10 sine 10. All of this together should give us, just give me a moment, please, 19.97. So for the y components, y equals 19.97. Now for the x component, we have 20 cos 90 plus 5 cos 20 plus 10 cos 0 minus 10 cos 10. That'll give me 4.85. So this, for my x component, 4.85. So basically, how we got this done is, let me quickly withdraw. You have to resolve every component into x and y, and every angle has to be on the horizontal axis. So let's say we have this. So we have the vertical y-axis and we have the x-axis. So we have this particular component, let's call it f1, at an angle of theta 1. We have this particular component, let's call it f2, at an angle theta 2. And let's get a third component, let's call it f3, at an angle to the horizontal theta 3. Now to resolve this, we result to an x and y component. X and y components. Okay, so just try to make this a little easier. If we result to the x and y components, every single force has to result to x and y. So let's call this x, let's call this y. So we have, in this diagram, we have f1, we have f2, we have f3. So in the x component, component, it will be f1 and the force cos theta. Now, if theta is in the positive x direction, it will be plus the force cos the angle. For for in the y component, f1 is in the positive y axis. So that will be f1 sine theta 1. F1 sine theta 1. So for f2, we will have f2 is in the negative x axis. This is negative x axis. So it will now be, since it's in the x component, it will be negative f2 cos theta 2. Now for f2, it's in the positive y-axis, so it will be plus f2 sine theta. Then for f3, it's in the negative x-axis as well, because it's in this axis. So it will be minus f3 cos theta 3. And in the y-axis, which is negative y, you have f3 in the negative y-axis, so it will be minus f3 sine theta 3. So once we resolve all of this, we now have our x components to be f1 cos theta 1 minus f2 cos theta 2 minus f3 cos theta 3. For our y component, we now have f1 sine theta 1 plus f2 sine theta 2 minus f3 sine theta 3, which was the same way we did we saw this our question that we had here. Now we have our y and our x components. What do you do with your y and your x components? Basically, create a triangle, find the resultant of that triangle, and that gives you your resultant. That gives you your resultant. So for instance, now we have y equals 19.97 and we have x equals 4.85. Both of them are positive. So we have a positive y and a positive x. So our diagram will look something like this: a positive x and a positive, okay, that line is not very straight. Okay, this looks better. And the positive y. So we have our x, we have our y. Then we have our resultant here and the angle of the resultant here. So our r square will be equal to y square plus x square. R will be the square root of y square plus x square. But our y is 19.97 square plus other x 4.85 square. This is going to give us 19.97 square plus 4.85 square equals 422.3234. So this is going to be the root of 423.3234, and this is equivalent to 20.55 Newton. Now the angle, this will be theta, right? Now in your SOCAT, it says the sine of this angle will be the opposite, so sine theta equals y over r, that's opposite over hypotenuse. We're working with Pythagoras theorem, so sine theta equals opposite over hypotenuse, and our y, so that's theta is the sine inverse of our y over our r. So our theta will be equivalent to the sine inverse of 19.97 over our r is 20.55. If we resolve this, the sine inverse of 19.97 over 20.55, it will be equivalent to 76.36 degrees. Theta equals 73.63 degrees. So R will be a single vector of 20.55 Newton acting at 73.63 degrees. Okay, so this is it. Thank you. Like, subscribe, and share for more contents like this. Thanks, and do have a wonderful